So for strawberries, what we're talking about, it's a bit unusual on coastal California because we don't have a lot of perennial crops. We have grapes, but it's not quite like the almond forest in the San Joaquin Valley. So what we're doing, for example, in like Watsonville, Salinas, and Santa Maria as well, we would be fumigating maybe in August or September. And then in October, we could be applying an herbicide. And then we're putting down a mulch. And then in November, we're transplanting, to be more accurate. And then for hand weeding, after the rain we had this winter and the winter of last year, we got a lot of rain, and weeds really flourish in rainy winters. And so when you have plastic mulch down and you have just tiny little holes, the only way you can get the weeds out is with your hand or with a wire hook. So reaching through the plastic, or actually I've seen people puncture lots of holes down in Ventura where they use clear plastic. In April, when it dries out, now it's dry enough, we can cultivate the furrows. And then, of course, we're harvesting through the season. The weeds, we've pretty well depleted the seed bank. So the weed control becomes less important as we go on in the season. So we have a few types of environments. We have the tops of the beds. If these represents 3 raised strawberry beds, we have the tops of the beds and the shoulders of the beds that are going to be covered by plastic. We have the furrows, which are going to be open. And so they're going to just be bare soil all season. And then we have the soil in the beds, and that is where the previous fall, prior to transplanting, we fumigate. Or we use ASD, or the project we're beginning to work on, and where I have worked in the past, where we're injecting steam in the soil. But most of the conventional strawberries are using fumigant, and the organics are using ASD. So those are the environments, and those are the different types of tools. And I'm going to sort of try to peel that onion and take the weed control system apart. So if you guys want to stop, I'll stop periodically, and if I'm not clear, please let me know. I hope you can hear me. So in the Strawberry Manual, this is the 2nd edition, you've got various aspects of weed control in the chapter there. You've got field selection, you've got sanitation, hand weeding and cultivation. That's physical weed control. We've got mulches, which block the weeds from growing. We've got fumigation, and then we've got herbicides. So they're all different aspects, different components. So we have lots of options. Strawberries are a very valuable crop. It's long-term in the field, and we have quite a few options. So this is field bindweed, and this is not a place to grow strawberries because it's impossible to management. Because most of the extension groups around the country, and even Canada and sometimes other, like South Africa, I've had a lot of questions because we have a lot of critical information here. A strawberry grower in North Dakota in the Red River Valley called me to say they had pick your own berries, and they had field bindweed, and they wanted to know what they could do about it. What can we do about that? This is probably one of the toughest weeds to manage, and it is impossible to manage. I told them, you need to grow strawberries in a place that doesn't have field bindweed. That's called field selection. Extreme example, but that's what we're talking about. Sanitation. These are windblown weed seeds, common groundsel, annual sow thistle. Very, very common. And the weeds seeds are in these those light puffy things that we've probably all blown on as kids. Seed that only weigh a few milligrams can blow for hundreds and hundreds of feet, perhaps even a half a mile. And so these things move around. You need to keep the area around the field clean. Then there's hand weeding. By the way, that the fellow in the blue shirt is Oleg Dogovich, is a farm advisor down in Oxnard. We were working on an alternative fumigant here and hand weeding it. Very expensive. Mulches. I had a graduate student, a master student that worked on different colored mulches. I'll tell you a little bit about the results there, but mulches are very important parts of weed control, and they cause a lot of complex interactions. They also keep the fruit from contacting the soil and becoming exposed. So, weed control. The high bar, the top, the brown and the black plastic are pretty good for weed control. They control most of the weeds. This is no herbicide, no fumigant. This is what you get when you use a tarp. Try to separate. The clear plastic is like a window. It does not block light. What is the mechanism by which plastic blocks the weeds from growing? What do you think? Weeds have green leaves. That's a hint. What do you think? There's a term, photosynthetically active radiation, basically getting the wavelength from the sun that allows photosynthesis to take place. You know, there's a lot of people, I tend to tease plant pathologists, you know, pathogens are they're all parasites. They depend upon the plants. Weeds are not lazy welfare bums of the pest world. They are self-sufficient. All they need is sunlight. If you block the sunlight, they can't grow. So in the brown and the black plastic, there's no photosynthetically active radiation penetrating it. The weeds can't grow. The clear plastic allows the photosynthetically active radiation to transmit. No good for weed control.
Good question.
Yeah.
So, go back to that chart for me real quick. So the brown, at least according to this chart, appears to let some par through, whereas the black doesn't let any.
Yeah, a little bit.
But then, interestingly enough, in the previous slide, brown was better at controlling weeds than black plastic.
There's a lot of things going on. So you have this plastic out for, over a year. And so during the winter, the plants are very small. You're going to have foggy, cloudy days. Black plastic absorbs what little heat there is from the filtered sunlight that's coming through the fog. I've seen this very clearly, at a place called Watsonville, that's like a half a mile from Monterey Bay. So it's very foggy, and so there's a lot of moving parts here. It's not just light. There's also temperature, the effect on the soil. Plastics, mulches are part of a very complex set of things going on. While we're stopped, we okay? Yeah.
Then why aren't there any brown mulches when you go drive through there? It's all mostly black and white mulches.
What? I didn't quite.
I was just I've been driving through the area recently, and I haven't noticed as many brown mulches. Most of them are black. And if they're brown or better at reducing weeds, why would you use more blacks?
Steve, would you repeat it for this side of the class?
It's not significantly different. If you did this 10 times, they would probably come out about the same, because if they're both blocking it. This is one, I think maybe 2 studies, and so this is the average of that. So it's not a difference to really spend a lot of time thinking about. Okay.
Do you know if black mulch is cheaper than brown mulch?
Is it possible what?
Is black mulch cheaper than brown mulch?
Yeah, I can't tell you off the top of my head, but that a lot of decisions are going to be based on that. You know, the farmer may say, well, we used brown last year and we got really good yield. So why are we going to switch to black when brown was good? You know, a lot of things are because they have experience with it, and the sales rep can provide exactly what they want at the width that they want, when they want it. And the other guy that's selling black, he said, well, it's one back order and I can't get it to you until maybe, until later, a couple of weeks later than they want. There's a lot of things going on. I mean, because they're using pallets of this stuff. So there's a number of weeds that are very difficult to manage with fumigants, clovers and fillaries and little mallows. And a lot of it, the reason is pretty simple. They have a seed coat that's hard for the fumigant to penetrate. And so the issue when you, for example, in Oxnard, where you have continuous strawberries use going back to the same field again and again and again, you build up these weeds, especially clover. One farmer, John Dullum, he's a highly experienced, very, very well respected. I'm not sure he's still living. He told me he called clover the kiss of death, because once you've got it, there's just nothing much you can do about it. And we don't have good herbicide options. Fillery and little mallow are also very difficult. Nutsedge is difficult to control with a lot of these. So here they are, the burr clover, red stem fillaries, sweet clovers, little mallow, cheeseweed if you like. You know these weeds, right? Nutsedge. Here in California, you can find, within the length of the state, you can find purple and yellow. But primarily on the coast, it's in the strawberry concern, it would be yellow nutsedge. And it's a perennial weed, and that thing on the left is a tuber, and it's about 3/8 of an inch in diameter. And it has, a seed will have one embryo. You kill the embryo, the seed is dead. With nutsedge, it has eyes on it like a potato, and they're growing points. And so you get one, you got 4 or 5 more to contend with. Nutsedge is tough. Plus, it's got a lot more energy than weed seed. These are the easier to control weeds. In conventional strawberries, you don't have much trouble with them. But in organic, I don't know what it is about. This is chickweed in the upper right-hand corner here. Chickweed and strawberries go together. If you're going to grow strawberries, you're probably going to see chickweed. And so we have bluegrass, which is a winter in the upper left. We have purslane, and then we have knotweed, which is kind of moderately difficult. And I did see out at the Strawberry Center, I saw some knotweed. It's a little difficult. So this is the concept of a seed bank. I don't know if you guys have taken weed science yet, but you need to talk about the seed, because this is, for annual weeds, this is where they live, in the soil. And so most of the seeds in the soil are dormant. It would be nice if we just irrigated them and they all came up. That's not the way it works. There's a lot of them are dormant. They're wild plants. They're not been selected like, tomato plants that we buy, or tomato seed that we buy from, Johnny's Seed. That you better get 99% germination. That's been bred into it. Weeds have not been selected for that. They can germinate for years. Some of them, like clover, can germinate for decades. So they're dormant in the soil, and then through a process that's quite complex, they become non-dormant, and then they can germinate, and then they become the weed problem that we see. Many of them also die. We never see them because they die, because they live in a very hostile environment with a lot of microbes that want to eat them. It's like a little tiny animal in the middle of the African savanna surrounded by predators. So what we're doing with fumigants and steam and with solarization is we're killing weed seed. So we're causing more rapid death of the seed bank. but we're not getting them all. And controlling weeds with fumigants is hard. None of this is easy. So you have to have the right soil moisture. This is sectagon, which is metam sodium. You're looking at 50 to 88% moisture, so you get good coverage of the soil. So why is moisture important for good weed control with fumigants? I'm going to tell you why. You know what that is? It's burr clover. What is it? Those are exactly the same seed, came off of the same plant. You see what's going on there? Kathy, who was a technician I had, she took this picture. She took sandpaper to a few and just made 4 or 5 passes with sandpaper over burr clover. When she started, they looked like the one on the left. So we put an unscarified one and the sandpapered one on blotter paper. So this one on the right is going to germinate. You can already see the radical coming out here. That's only 12 hours after 12 hours of imbibition. So why is it difficult to control weeds under dry condition with fumigants? Because you can't get it in to the seed. So we think about it. There's a clover seed from the side, and it's full. The embryo, and that white in the center, is full of cells. And when they're wet, the cells are expanded. They're full. There's a vacuole full of water, expanded. That's what makes plants appear to have good turgor, that the vacuoles are full. What we're trying to kill with fumigants is the mitochondria, respiration, which is critical for maintaining life in the weed seed. That's what we want to get. So when we're dry, everything is compressed. You ever buy a new sleeping bag that was all compressed in a bag, and you pulled it out, and it expanded greatly, or one of these mattresses that come after hydraulic compression, you could never get it back. That kind of compression is what you have if you have microscope pictures of a dry seed. Everything is compact. When you wet it, it swells. You can't get a fumigant into the dry because it's just too restrictive. You don't have enough time. The fumigant needs access to the seed within a few hours. Otherwise, it starts to degrade. Does that make sense? You need that open, swollen, wet. That's how you get stuff. Okay? This is a key to how to use fumigants in soil. So we have data on this, and we actually published it. We treated dry common purslane seed with a rate 1,000 pounds per acre equivalent of chlorpicrin. You'd never be able to do that in the field. But you can do it in a jar in a lab, and you couldn't kill it. Whereas when it's wet, it's easily killed with just a very small amount. So that's the difference. Why couldn't we kill the top one? Because it's dry, and everything, and all the cells are shrunken, swollen, and there's no way for the fumigant molecule to get in and kill it. That is the key to killing weeds with fumigants, because the old joke is that Vapam, which is one of the fumigants that we do have available primarily for weed control, is that it works about half the time, which tells me half the people using the Vapam know how to use it, and the other half don't know this, what I just told you. Moisture is key. Okay? I hope that's of value. So what's going on, the easy ones have permeable seed coats. The fumigant can get in easily. The hard seed coats, the burr clover, the filaries, the mallows, and the clovers, I should group them together. They have basically, it's like the seed coat is a seal. And so these are basically clover-like seeds. These actually are vetch seeds, which are closely related. And it basically has very, very tight seed coat, very difficult to kill with fumigants. There are other things that work. So this sort of the summary, so we're talking about controlling the seed bank. You can kill seeds, weed seeds, without germinating them. Because you're getting into the seed. This is really, when I came here, people were going, well, you need to germinate the weeds. Well, yeah, it's easy to control germinating weed seed. That's no problem. But if you're going to get good weed control, you need to kill part of the dormant seed bank. You see the difference? You need to kill most of the weed seeds to get good weed control for strawberry beds, whether they're germinated or not. So fumigants are sort of unique, and not a lot of people outside of California talk about this aspect of weed science. But they're one of the few types of treatments that you can use to kill the seed bank. But fumigants have limits. They can't get into the hard coat seeds because of the reasons I'm talking about, because they're protected. And so what happens in places like Mr. Dellum's fields that he's grown strawberries on for 10 or 20 years, and he used methylbromide when he could, and using chlorpicrin now, he builds up a population of clover that is resistant to the fumigant. And so it creates a lot of trouble for the grower. So clovers you can kill when they germinate, but when they're sitting in that hard seed coat, they're very difficult. So another aspect of fumigants and using them for weed control, you need to know that the weed seeds have a limited amount of energy. So they're very, very small. They have carbohydrates, they have starches, they have oils in the seed that allow them to reach the soil surface. But they can only go 1 or 2 inches. If they come from 3 inches, a lot of them, they will not make it. They will simply die, whether the fumigant kills them or not. The primary weeds that come from deeper in the soil are things like nutsedge. Now, nutsedge is a different deal. And field bindweed, these perennial weeds are a different ballgame. And that's why you need to avoid them if possible. Although nutsedge and strawberries down in south of here is becoming more of a problem. It's building up, it's being selected for. So this is a typical Oxnard wide bed, also Santa Maria, very wide bed. You may have in this one I actually measured like a 48-inch bed top. I think it was a 68-inch bed. That's measured from the center of the furrow to the center of the opposite furrow. And so there's the center of the bed. The drip tape might be 8 inches from either edge. So we're applying fumigant by drip chemigation. So we apply it through the drip tape, and we want to spread it laterally. If we're going to get good weed control, we need to have that lateral spread across the bed. So there's really only 2 primary fumigants. There is chlorpicrin, and then there's telone, or 1,3-dichloropropene. And they come in very commercial formulation. There's inline. Now it's mostly PIC 60 or PIC 80, which is the 60% chlorpicrin, 40% or 38% or something like that of 1,3-D. So there are combinations. So we don't have a lot of choices. Well, we don't have hardly any choices. So really, those are the two that really can control pathogens. I'm primarily talking about weed control, but one thing I want to keep you to keep in mind is the main reason that people are paying for fumigants is to control diseases. Weed control is sort of a bonus part of it. But as you can see from those budgets that I passed around, is that weed control is not a trivial cost. And when people started using methyl bromide in 1960, they liked the disease control, but they really liked the weed control too. So it's, the way I put it is the fumigants, about 60 or 70% of the reason, the money that they spend on fumigants is for disease control, and the rest is for weed control. I don't know if everybody will agree with that, but that's sort of the ratio that I've worked out over the years. I think it holds up. But I can't get a big head because weed control is not the driving factor here. It's disease control. So, yes?
With the banning of a lot of like conventional fumigants, do you see a resurgence of like soil steaming and that technology at all, or not necessarily?
Yeah, I do. That's why I'm building a steamer. I'm not talking about that today. But come up to Salinas on the 27th of June at our field day at Hartnell College, and I'll show you what we're doing. But yes, but yeah, I'd love to talk to you about that because that's my baby. That's what I'm working on now. So yeah, fumigants. You know, there's a lot of baggage here. But these are we talk about LD90s. You know, when we talk about toxic materials and the people that we don't want to expose humans to, we talk about LD50s. But when we talk about pests, we want to control them all. So we start talking about LD90s, and so these are basically the relative doses. So purslane is easy; it's about 80 pounds. You can kill it with inline, which is a mixture of 1,3-D and chlorpicrin. And chickweed is a little worse. Knotweed is a little higher, and then the mallow and fillory, you can't really get enough of these fumigants to control it. You'll get some of it, but not all of it, and you won't be satisfied. And that's why the Strawberry Commission recruited me back in the late 1990s, because they knew that weed control was a weak point in the methyl bromide alternative world. So far what I've told you is that weed seeds need to be moist. You need to get a sufficient dose to the target. And so what else can we do? We have herbicides. Best advice I ever had that I didn't, or the worst advice I ever had, and I'm glad I didn't take it, was to work on, I was told not to work on herbicides. Well, I didn't listen to that. There's a lot of things we can do, and they help a lot. So goaltender, this is oxyflora the Chateau, which is flumioxazin. Those are very important, and they're widely used in strawberries. After transplanting, there's some grass materials, Post and Select Max, that are available. So how do you use these? Start with fallow beds. Okay? We can spray the herbicide right at that point before the strawberry planting. We can treat that entire field, furrows, bed top, the whole business. So here's goaltender. So we basically need to apply the material, and then we put the plastic mulch down. We need 30 days between the herbicide application and transplanting. So important points, we need that 30 days. That's the requirement. We know that's safe. That's what the label says. That's what I have to say. We're using 1 to 2 pints of Goal, or a half a pint to 1 pint of goaltender. 2 formulations. of the product. The goal, this is the first one, is Goal 2XL, which some growers tell me is a little bit cheaper. Goaltender is a nice product, but it's more diluted. So then we install the film. We want to do that before we transplant. If we just do it the day before, that's good enough. It needs to be present when we transplant. So Malva and Fillery control with this herbicide is good. Fumigants didn't get these. So this is a good thing. This is why these are useful and why they're saving growers money. So what happens? Why the big deal about having the plastic present? Well, it protects it. This, when we have a open bed and we have goaltender on it, we get bounce. The soil bounces and it sticks to the underside of the strawberry leaf, and it causes injury. I mean, it doesn't kill the strawberry, but it does hurt it. It recovers. Chateau is an excellent herbicide. Basically the same use pattern, quite a bit more concentrated, just a very small amount, 2 to 3 ounces. Again, you have to put it on fallow ground. It controls Malva. It has quite a bit of clover control. It's not bulletproof, and fillery. So if I'm choosing an herbicide, I'm a strawberry grower, this is it. It's a good product. So after strawberry transplanting, I got grasses coming in. I want to plant a cover crop in the furrows to control erosion. A lot of people told me they're interested in sustainability, soil health. That's something that's good to do. I can then go in at the time of my choosing and spray it with an herbicide. Absolutely safe to the strawberries. Kills the grass. So these are good herbicides. Goaltender, Goal 2XL, Chateau. They're basically applied to the fallow. They're very effective. They control some weeds that the fumigants don't. And then Select Max and Post are herbicides for the control of grass weeds. We don't have a lot of grass weeds in strawberries, so they're really most useful for killing volunteer cover crop and taking down the cover crop in the furrows. We're planting in the furrows to control erosion. We haven't solved all the problems. There's mare's tail, caniza on the left. This stuff has a windblown weed seed and it can go for miles. It is a serious problem, especially out in the San Joaquin Valley. Big problem in grapes and along ditch banks, a tough weed. So if you have it growing in a ditch near your strawberry field, you want to get rid of it. Hard to kill. And then nutsedge. My colleague Oleg Dogovich down in Ventura tells me about, and I've seen some of these fields that basically are just swamped with nutsedge. We don't have a good solution for that. So, yes?
I remember there's an herbicide that you can use in lima beans that is going to get to the nutsedge, and then you can plant strawberries or something like that.
So, are you talking about matrix or
I don't recall, but I remember that there was something that you could do in nutsedge. Just planting a different crop, in this case lima beans, just spray that herbicide, and then you can do something else.
There's a product called Sandia that's pretty good on nutsedge, but the trouble is it really hammers strawberries. And it would be nice, and the company brought it to me one time as coating on the inner side of plastic. And so we tried that, thinking it may be safe to the strawberry, but the nutsedge comes in contact with it and it kills it. It still damaged the strawberries. It's just like you sprayed it on them. So we haven't, the only thing we've remotely found that works on nutsedge for strawberries is like an Eptam treatment at the season end. So it's already too late. You go into the field to try to clean it up for the next year. So you go in with Eptam, use the drip system to inject it, and it does a pretty good job of killing it, but you've already had the problem for the previous crop. It's trying to reduce the tubers. So it's a tough. This is one thing that does help a little bit. There's Sectagon, there's Bapam, there's Kpam, which they're different salts of metam. So this is one, and it helps. So what we're going to talk about a little bit about is sequential applications. So here's some data again, LD90s, showing the susceptibility of the weeds. And nutsedge, you can, there is a rate, I believe the maximum label rate is 100 gallons. And so you can get nutsedge with this material. And this is the rate that's used to kill the other ones. They're different. So what you can do is use your base fumigant like Pick 60 or Inline, and then 5 to 7 days later, you come in with a sequential application of metam. Not an easy thing to do because guess what? You're doing 2 fumigant applications. So the ag commissioner where you're doing this is going to be watching you. They're going to know you on a first name basis. So you apply your base fumigant, inline chlorpicrin or Pick 60, and then that's for disease control, and then you come in with a sequential application of metam sodium. Isn't cheap because you're using 2 products. The herbicides are cheaper, but they're not effective on the nutsedge, not as effective. So here's some data. I mean, this treatment with chlorpicrin followed by metam sodium, it reduced the weed population by 32% compared to no metam sodium. So it does help. Here's some more data showing following Inline, and the metam sodium contribution to the weed control improvement was 21%. So is that worth it? Those are the kind of decisions that growers have to make. So nobody likes fumigants. They're expensive. They're highly restricted, and so they don't do any. When they leave the farm, they're not doing anybody any good. What we want to do with fumigants, we want them in the soil. We want to trap them there. We want them to kill our pests, and then we want them to degrade so that we can safely come in and transplant strawberries. So their industry has responded by creating these films, these impermeable films. There have been various names: virtually impermeable film, totally impermeable films. They are designed to trap fumigants in the soil. That has impact on the pest control. Good impacts, by the way. And the ag commissioner, by the way, they tend to like it because there's less trouble with neighbors. The last thing you want to do is has complaints coming into the ag commissioner's office because a lot of these materials stink. If anybody has ever been exposed to chlorpicrin, you better grab a Kleenex because they're lacrimators. They cause a tearing. Not pleasant. They don't smell good. So there's good reason to keep these things in the soil, out of trouble. So this is a trial that we did in Salinas. We used methyl bromide as a standard, and back when we used to be able to do that in research, and then we use a Pick Chlor 60 compound, 50 up to 400 pounds. And we used an impermeable film. So what it is, they have this, they're like vinyl alcohols. They're very fragile, and so you have to package them in standard polyethylene plastic. So putting this all together, so basically it's a sandwich. Some of these have multiple layers, but guess what? They work. They trap the fumigant. So we did the work, we measured with a very simple meter, and the data I'm going to give you is meter readings. Am I going too long?
I'd say you got 5, 10 minutes.
Okay. So we measured at a sequence of time from 3 hours up to 96 hours. We measured that under impermeable and standard film. So this is what happened. So this is time. This is the time of fumigation all the way out to 120 hours. So the standard film, it starts out high, but it rapidly goes down because the fumigant is going through the plastic. It's penetrating it. It's leaving it. Whereas the impermeable film is much slower. This is several days. So the fumigant is trapping that. So when you trap the fumigant, it's working for you. It's killing the pests in the soil, which is exactly what you want it to do. So let's see the results. So these are the meter readings. So the high number means there's a lot of fumigant there. So there's no fumigant here because this is the control. This is 50 pounds, 100, 200, 300, and 400. So there's a lot of fumigant here. This is the impermeable film, and this is the standard film. This is 8 hours. So I went out there in the dark with a light, and we were taking meter readings 8 hours after the application. And what this is showing, at 200 pounds, we've got 855 compared to 565. So this is a lot of fumigant, 400 pounds. Look at the difference. This material is trapped in the soil. That's what we want. The standard film is letting it go. So what does it do to the pest? Well, in tests you have to sort of look at the marginal. If you go with methyl bromide, it kills everything. So you don't pick up a difference there. With 400 pounds, this is a lot of fumigant, regardless of what you use. But at the lower rates is where you see the difference. So this is the lower number here means there are fewer weeds. That's a big difference. So why are there lower weeds under the impermeable plastic? Because the other ones are dead. These weren't killed because the fumigant rate declined rapidly. Nuts Edge, same type of trend, 100 pounds, we're getting a difference. We're getting better weed control where we trap the fumigant. We got more yield, 100 where we saw a difference. The red bar is under the impermeable film compared to yellow of the standard. The two asterisks up above mean they were significantly different. So we got better yield. Why did we get better yield? Because at this field I happen to know there's macrophyllena and there's pythium, which causes some reduction in yield. The better fumigant retention under the TIF controlled it. There's the picture. It's in the interest of time, I won't point out the differences. They're very subtle. So retention of fumigants is a technology that's come into fruition and is well accepted by the industry. So I'll leave you with this. The weed seeds that you're trying to control, you need to have the right moisture if you're going to use fumigants. You need a sufficient dose. And the way you can get a sufficient dose is use these impermeable films to trap it. You're going to get more for your money. If you have to, you can use a sequential application of metam sodium. You can also, of course, use herbicides if they'll control the weeds. So that's what I have for you. So basically looking at the spectrum of physical weed control with the tarps, with fumigants to control the seed banks, and herbicides which provide some residual control. So that's what we have. The hand weeding, that is expensive. That's why I passed out that budget. We're talking real money here. So.
All right, thank you, Steve.